Hello students, welcome back. So the fourth part of this factorization of algebraic expression. This time round we want to look at identities. So what are identities? Well, identities, these are the identities that we're talking about. We know that if we have a plus b squared, they expand out to a squared plus 2ab plus b squared, right? Similarly, if we subtract, it will look like this. The 2ab portion get reversed. And when we expand them, one with a plus b, the other one is a minus b, the product of the difference, we get a squared minus b squared. So if this is true, then the reverse process must be true. So this identity, it is good to actually memorize them and know them by heart, because it will speed up your processes a lot quicker, right? So how does it work, right? So if I will look at this example, right, x squared minus 16. So this is a quadratic, right? If I want to use my cross method, it's very awkward because I have x squared, x by x, means x squared, and then we have negative 16 over here, and over here is actually 0x, and it's quite weird. Okay, we feel very uncomfortable. It's not that it's impossible. It can be done. If you want, I can show you in class, but there's a much quicker way. If you know your identity very well, you know that this gives us x squared minus 4 squared, right? So this is a scenario where we have a squared minus b squared. That means it's going to be a plus b, a minus b. So in this case, it will be 4 plus x, or x plus 4, and x minus 4. And we are successful. See, it doesn't take too long. So this is useful, right? If you know your special identities well, you can actually factorize these cases very, very quickly. Okay, so it's just another example. 81x squared minus 25. We look at this and say, okay, this is actually 9x squared minus 5 squared, right? So back to the scenario, this will be 9x plus 5. Okay, same scenario over here, 9x minus 5. Very quickly we can sort this out. All right. Now what happens if it's fraction? No issue, right? Because I look at 4, I look at 25, they are all perfect squares. So this means that this is actually 2 over 5x squared minus. Now here's the thing about 1, right? Sometimes we forget that 1 is actually the same as 1 square. Right? 1 square. So this works, right? So this gives us 2/5 x plus 1 multiply with 2/5 x minus 1. Exquisite, yeah? Right? How about brackets like this? Well, same scenario. We're going to treat the entire bracket here as though it's its own entity, right? So let's mark it out in red. So what I have now is we have this x squared minus 1, right? This portion here is squared minus 1 squared. So this will give us x squared minus 1 plus 1 times x squared minus 1 minus 1, right? So this simplifies to x squared by x squared minus 2. There we go. So that's how it looks like. Okay. Are there more examples? Oh yes, there's more below. Why is that on the right side of the screen? Okay. We'll look at that later. Right? So example E, once again, this time round, hey, wait a minute, that's not square, that's cube. But remember, in our earlier lesson, we mentioned that whenever we can extract out common factor, we should do that first. Is there a common factor here? Yes, x is the common factor. So when we take out x, we have 4x squared minus 49, right? So now we keep the x to a side. Over here, this becomes 2x squared minus 7 squared. So repeating the process that we have been working on, this becomes 2x plus 7, 2x minus 7. There we go. Okay, so let's look at what's on the right side. It says factorize this, okay, without expanding the expression first. Well, without expanding, so I'm not going to expand. In fact, I'm going to factorize, right? So I'm going to take this portion here and this portion here and treat them as my a and b. So I will end up with p plus 1 plus p minus 1, right? Multiply with p plus 1 minus p minus 1, right? So just use the special identity. So this becomes p plus 1 plus p minus 1. On this side, it is p plus 1 minus p. Remember, minus a negative 1, this is plus 1. Okay, we have to be careful here. So that simplifies to 2p multiplied by 2, right? There we go. Okay, so this will be 4p. Hey, amazing. We have successfully simplified it. But wait a minute, some students were asking, is this factorized? Sure, it's 4 times p. One of the factor is 4, the other factor is p. It is factorized. Okay, the question is not wrong, but yes, it's just a very unique question where we end up in this kind of scenario. Very interesting one, just for practice purposes, right? Okay, so now that we have completed this, okay, so over here, we can of course use the cross method as well, okay, but I'm not going to go into that because it's not necessary. Okay, so it's just to confirm the fact that although we know the special identities, we can actually use the cross methods on the special identities. We can, right? The issue is it takes longer. That's why you are encouraged to know the special identities very well, because it really speed up the process of solving all these mathematical problems really quickly, right? So here we have this scenario. You can use the cross method, right? It says all use the cross method, but I'm going to encourage you to actually just use a special identity. How to know when you're supposed to use a special identity? When we observe that the terms, the first term and the last term, they are perfect squares, right? So that gives you the hint. Is it always the case? Not always, but it helps, right? So in this case, I see x squared on my first term, I see 36 on my last term. I sort of know that, hey, maybe this is the special identity case. So we try it out. This will be x squared, right, plus 2x 6 plus 6 squared, right? So you can check, is a squared plus 2ab plus b squared, which will give us a plus b squared. There we go, successful. Okay, so it doesn't take too long. If you know your special identity very well, this entire process takes so fast, right? Just a split second. Okay, you can use the cross method, but as I mentioned earlier, cross method you got to work out and test out all the different combinations. It's time consuming. It works, but it's time consuming. Okay, so another example over here, right? So over here I can see straight away this is going to be 3x squared, right? And the other end will be 2 squared. So in the middle, I just test whether is it the 2ab scenario. So 2ab b squared. Does it work? Double check. It does, right? So this gives us 3x plus 2 squared. Very quickly, right? Here's another one. Again, I see x squared, I see 25. Hey, perfect squares, right? So maybe it works. So let's try. Is it x squared minus 2ab? 2ab this time is 5 plus b squared. Double check. Each term works. Yes, it works. So this gives us x minus 5 squared. Okay. Finally, another example. 169 and 4. Sure. Right? 169 is 13 squared. So 13x squared. Right? Minus 2 times 13 times 2. Is it 52? Yes, it's 52 plus 2 squared. Right? So this gives us 13x minus 2 squared. There we go. So knowing your special identities well really helps. Really helps. But feel free to use cross method to try and test and confirm that this thing works as well. Alright? Okay. So with this, okay, here's some summary. Not all quadratic expression can be factorized using either a cross method or special identity. Not all, right? Okay. But don't worry, okay. What should we do if we encounter quadratic that cannot be factorized? That will be a topic for the next chapter. Okay, we will actually talk about it in the future, right? Actually, not the next chapter. Next year, Sec 2, you're Sec 1 now, right? Maybe. Okay, we'll see how it goes, right? So don't worry. So just to consolidate all the 4 methods that we learned, here are some practices where we just use all the different methods. Okay, so let's try just for practice sake. So here, let's try to recall what did we learn. Well, first we learned to extract common factor, right? So I see 14, 21, 7. I can extract out 7. And is there a letter that's common to all? Yes. C and D is common. So I can take C and D out. So I'm left with 2a plus 3c minus, well, 7cd, take out 7cd, I will have 1 over here, right? So there we go. So that's the first example. Sure. How about this example, right? This example we do grouping. So let's see. First group, I can take out 3a over here. I have m minus 3. Looks good. Second group, I can take out 4b. If I take out 4b, I will have 3 minus m. And then we learn that m minus 3, 3 minus m, we can actually take out the negative 1, right? So m minus 3, in this case, let's take out negative 4b instead. So I have m minus 3. Now the bracket parts is common. So m minus 3, 3a minus 4b. Right? Now the next one, special identity, right? So this is 3a squared minus b plus c squared. So this gives me 3a plus b plus c. Right? Now, caution here, it will be a good habit actually to have them in brackets first before we simplify, right? And we have 3a minus b plus c, okay, because of this situation over here. So we'll end up with 3a plus b plus c, and here will be 3a minus b minus c. Beware, right? It's minus b minus c. Okay, successful, right? How about this one? Well, this one will probably be a cross method, right? So I look at this and I can say that this is okay. M, this will be plus 4, m plus 5. Then you're asking me, where's the cross method? Haha, here's the thing, right? Because you're beginners, you are just starting to learn this, you use the cross method, and you actually write out the cross method as your rough work. With enough experience, it is absolutely possible to do the cross method in your mind mentally. And that's what I just did. But of course, you can try it out, right? Do the cross method, right? This is m squared, m by m, 4 here, 5 here. We work this one out, positive, positive, positive 9. And then we have positive 4m, positive 5m, positive 9m, and everything lines up properly. See, it can be done, right? So for the more advanced students, I'm hoping you should be able to do this mentally already, straight away, right? Do we have more examples here? We have more practice over here. Why not? More practice is good. Let me remind you again that when you see practices like this, feel free to pause the video, try it out first, then you compare your answer with mine. That's the more efficient way of learning rather than to watch demonstration all the time, right? Okay, so what do we do here? Okay, so in this case, I will extract out 25, and that will give me x squared plus 4xy plus 4y squared, right? And I look at this and say, hey, is it special identity? Maybe it is. Let's try it out, right? Is this x squared plus 2x y? Sorry, let's go back. It's 2y plus 2y squared. Check each term, every term check. It works. So this is 25, and then we have x plus 2y squared, right? How about the next one? Same way. Well, this scenario is actually, let's take a look, right? We can't do the square over here because the 5 is not a perfect square. Is there an error in the printing? I was hoping it's an error in the printing that should be a 25, right? Could be, okay? Either case, maybe I were to take out the... Oh, no, it works. Well, we take out the common, we take out common factor, we can actually take out 1/5, right? If we take out 1/5, okay, I mean, it still works, right? Take out 1/5, we have 9x squared, and then we actually have 25y squared over here. See, beautiful, I like this question. This is great, right? So this works, right? Because 1/5 times 25 give me 5. So 1/5 is still there, right? And this becomes 3x squared minus 5y squared. Okay, so that becomes 1/5, 3x plus 5y multiplied by 3x minus 5y. Oh, lovely question. There we go. It works. Right? Okay, how about the next one? Same scenario? Probably, right? So, what happened? Over here, I take a look at this and I say, okay, this could be 6x squared, right? Minus, on this side, it will be actually 7x plus 1 squared. So that will give me 6x plus 7x plus 1 multiplied by 6x minus 7x plus 1. Using the special identity, then we simplify as much as we can. 6x plus 7x plus 7. On this side, it is 6x minus 7x minus 1. We end up with 13x plus 7 multiplied by negative x, negative 1. And of course, if this makes you uncomfortable, we can always extract out the negative here, and to have, in this case, becomes x plus 1. So this works, right? So, I mean, this is sufficient. This is even better, right? Another scenario here. Okay, so again, we see the fraction. What we can do, right, in this case is actually recognize that even fraction can be perfect square, right? So what I see here, okay, with enough experience, is to see that this is actually g over 2 squared. And then, does it match the 2ab? Well, g over 2. And the b in this case, right, is going to be h over 4 squared. So if I put the h over 4 over here, does it line up? Let's check. Right? Oh yeah, it does. Beautiful. Right? So this is my a squared minus 2ab plus b squared scenario, which gives me a minus b squared. There we go. Nice, right? These are beautiful questions. Love it. Okay. We have more. We have more. So what can we do over here? Over here, we can... my first instinct is, let's see if we can extract out common factor, right? Common factor here will be 3x. Sure, right? So if we take out 3x, okay, what do we have left? Okay, this term we have 2 plus y, and then we have minus 6. Yeah, minus 6, right? And then y plus 1. That's what we get. Okay, so we just simplify this. Right, so we 2 plus y minus 6y minus 6, which simplifies to negative 5y and negative 4. Again, if the negative makes you uncomfortable, we can always extract it out. So negative 3x, and then we have 5y plus 4. Well, that works for me, right? And is that the last example of the day? Oh no, there's more, right? There's more. Okay, so let's finish it up. Why not, right? So we have this situation. Okay. What we can do is we look at this portion over here, and we recognize that, hey, there's a 2 there that I can extract out, right? Yeah. So maybe we can try it, right? So let's try. So we have x squared, and then if I will extract out the 2, it'll be 2. We have y squared minus 4. Okay. And then this thing squared. Minus y squared minus 4. Okay. So this looks fine. And then I recognize that, hey, the 2 terms, they are all squares, right? So if I were to put them together, right, this will actually turn out to be 2x y squared minus 4, right? This thing squared minus y squared minus 4. Does it work? No, it doesn't, right? So let's reverse the process. Well, some questions has more than one way of handling this. Okay. So what happened is, instead I should take the 2 and bring it outside, right? So 2 squared, right, is 4. So I have 4x squared, right? And I have y squared minus 4 squared minus y squared minus 4. Now here, what happened is y squared minus 4 is common. So let's extract that. So we have y squared minus 4. And then we will end up with 4x squared, y squared minus 4 minus 1. Okay, so this will be, now y squared minus 4 is y squared minus 2 squared, which gives us y plus 2, y minus 2, right? Now on this side, we can maybe expand out to see things clearly. We have 4x squared, y squared minus 16, right? 16x squared, and then minus 1. Can that be factorized? 2, 1, 2, no. Okay, so that's the simplest form, I guess, right? So that's what we have. Okay, so I know that this last question is these last few questions is tougher. If you have some success, congratulations. If not, do not panic. As I say, a lot of this comes with a lot of experience, so just keep practicing, and eventually I hope you get the hang of it. So the very last section, the very last page, okay, this time around we're back to numbers, right? Okay, but it just shows you the power of all this factorization that allow us to actually solve this type of questions very quickly without the calculator, right? So what do I mean? I mean, if you know your algebraic identity very well, these questions can be done very quickly. Why? Because over here, I'm going to look at this and I say, okay, this is actually, right, this scenario, right? This scenario. Okay, and because I know my identity very quickly, right? This will be 1. In fact, I can actually break it up further, right? Now let's just leave it here, right? So this will be this 1200 squared plus 2 1200 times 1 plus 1 squared. Okay, so again, 12 times 12 is 144. You should know this. Therefore, 1200 times 1200 will give us 144 and then 4 zeros. So 144, 4 zeros, right? Over here, 2400 plus 1. Now we put them back together. It's 144, then 2401. There we go. Okay. Now over here, what's the situation here, right? The situation here is this is going to be 400 plus 3 times 400 minus 3. So this is a plus b, a minus b, which is the same as a squared minus b squared, right? So 400 times 400 is going to be equals to 16 and then followed by 4 zeros minus 9. Okay, so from here we can just work it out accordingly. It's going to be 15999, and then the last one will be a 1 because we minus 9, right? Okay, and how about this scenario, right? Again, this scenario is going to be a squared minus b squared, so it will be 29 plus 39 times 29 minus 39, right? So 29 plus 39 is equals to 68, and then we're going to multiply by negative 10, which will give us negative 680. How about this one, right? Well, this one we have 91 squared minus 9 squared, so this will give us 91 plus 9. You know where this is going already, and 91 minus 9. Okay, so this is 100. Multiply by 91 minus 9, this one is 82. So it will be 8200. It's nice, right? Okay. Well, how about question 2? Well, question 2, if x squared plus y squared is 80, xy is 20, find the value. So we want to find this thing, right? So what we can do is we recognize that x minus y squared is actually x squared minus 2xy plus y squared. We rearrange it. This is x squared plus y squared minus 2xy, right? Which gives us 80 minus 2 times 20, which will give us 40. Not too difficult, right? How about this scenario, right? This scenario, they want us to find the value of x plus y. Sure, why not, right? So what we can do is, we start from over here. 2, wait, Apple Pencil, come on. 2x squared minus 2y squared is going to be 125, right? So this tells us that x squared minus y squared is equals to 125 divided by 2 is 62.5. Is my mental calculation okay? I mean, if you have a calculator in front of you, do use it, right? But yeah, it's 62.5. So now, x squared minus y squared is x plus y, and x minus y, and this is 62.5. Now we know that x minus y is equal to 2.5. So this means that x plus y times 2.5 is equal to 62.5. Therefore, right, x plus y is equal to 62.5 divided by 2.5, which gives us 25. Successful, right? Okay, right, final example. The surface area of each side of a cube is this. Okay, sure. Find the length, right? So to find the length given the surface area is to actually find the square root. Okay, so what we need to do is we have x squared plus 4x plus 4 is actually equals to x squared minus 2x 2 plus 2 squared. So we factorize this, this is actually x minus 2 squared, right? So this is actually the area. So therefore, length equals to square root of x minus 2 squared equals to x minus 2, right? Part 2. Now we find the volume. Sure, right? So volume is equals to x minus 2 to the power of 3. Okay, so I mean, you have not learned this topic called binomial, so you can't expand it straight away. But you can always, right, do it manually, okay, in this manner, right? So this will give us x squared minus 4x plus 4 times x minus 2, right? Or if this confuses you, you can always reverse the process, because I know some of you like the longer polynomial on the right side. It doesn't matter, right? Because a times b, b times a, they are the same thing. So we have, wait, my mistake, right? This is a plus, right? So it's positive. Okay, plus 4x plus 4. So this will give us multiply everything by x cubed plus 4x squared plus 4x plus 2x squared plus 8x plus 8. Putting that all together, x to the power 3. Then we have 6x squared, 12x, and 8. There we go. Okay. So with this, I hope you get used to the idea of factorizing, and more practice. Be good. Have a nice day.